Hi, I'm Brian McDonald from O'Reilly Media. I'm here talking today with Pete Hunt from the Instagram team at Facebook and Spike Brehm from Airbnb. And we're going to be talking a little bit about polymorphic JavaScript, isomorphic JavaScript.
Isomorphic, yep.
So tell me what that is.
Well, it's funny, the name gets a lot of flack actually. But it's, so ISO means same, morph means form. So the idea is that it's JavaScript that can run in multiple environments. Like the same piece of code can run in multiple environments. So in Airbnb's case, we're mostly interested in sharing code between the client and the server.
Right.
So running, whether it's like application code, so like model code, logic, templates and views, routing, date formatting, stuff like this, sharing that same code between client and server, which is a fairly novel thing in the last few years.
Okay, and at Facebook?
Well, I work on a system called React, and it was kind of designed from the ground up to support this use case. And the reason for that is not because we want to immediately rush to writing all of our code in JavaScript, because as a lot of people know, Facebook is a PHP shop and Instagram is a Python shop. But we want the option value there. So there's a lot of benefits to being able to run the same code on the client and server. Like Spike said, it's kind of a developer efficiency thing, but it's also a performance thing. So if you can render pages without waiting for the JavaScript to load on the client, you're going to not only get a faster page load, but you can also improve your search engine ranking because your content's actually in the page rather than downloaded as JavaScript separately.
So how do you accomplish that behind the scenes?
Well, there's a lot of different components. One thing I like to say is that templating is the gateway drug to isomorphic JavaScript.
Okay.
And in some ways, React is kind of like a view templating layer, if you will, because that's a place many people start. People start with like sharing handlebars templates between client and server, or mustache templates, or whatever, or in React views, React components, and that just like taking data and matching it with a template and generating HTML is pretty trivial to do, whether you're like on Node.js on the server or in the web browser. But once you do that, it turns out there's a lot of other things you need to build to actually have your app be able to render on both sides or share code. So for us, we started with trying to render our handlebars templates and a Rails app. So okay, we need a JavaScript runtime on the server, but then you have your routes are duplicated, and then like your model logic is duplicated, and maybe your whatever like view helpers or like name formatting for a user, all this stuff becomes duplicated. So you can either maintain it in two different languages, or you can find a way to kind of unify that and share that code between both sides.
Yeah.
And it's not just sharing the code too, because a lot of people write JavaScript with the browser in mind, or they write it with Node in mind, and you have to write it in a completely agnostic way. So a really good example is if you want to get the current URL of the page, a lot of times you'll look at window.location.href, which will throw an exception when you're running in the Node environment. Also, if you want to use some Node API like the path module or something, you need to make sure that the client-side implementation exists as well. So there's a lot of different tools that can help you with this, and then one of them that Spike likes, I think, is Browserify. That works really well for this.
Yeah, Browserify is sweet. It's written by Substack. It's kind of a famous Node guy. But the whole idea is it allows you to take your CommonJS modules. So CommonJS is the module format that Node uses. So anytime you see like the require function and module.exports, that's CommonJS. So you can take a CommonJS module and package it for the browser. So you can do like require, relative requires. So you can keep your files in little small modules. You can require dependencies out of npm. So if you do like var underscore equals require underscore, it'll actually pull that from your node modules directory. Create a browser bundle with that, and you can use that in the web browser. And you guys switched from that, or you use a different tool, right?
Yeah, I use a tool called Webpack, which is kind of a more flexible Browserify, and it supports a lot more use cases. So for Instagram, for example, we can't create a single giant bundle. We need to create multiple bundles because you might hit the photo page, or you might hit the web feed, or a profile, or a profile page, or whatever. And you don't want to have to download. If you're only looking at a photo page, you don't want to have to download all the code needed to render the profile page. And even if you're using an isomorphic approach, if you want to get your application into the same state, you want to generally be running the same code on the client that you do on the server to render the page. So what Webpack does is it basically lets you say, okay, what are your entry points? And so I say, okay, my profile page is an entry point, my photo page is an entry point. And what it will do is it'll say, okay, it looks like the common code shared between all your entry points is, is maybe it's React and Backbone or something else. And it'll put that into one file that can be cached for all of these page loads. So if you go to the profile page, you only download the profile page code that you need. And then when you go to the photo page off from the profile page, you'll only download the code unique to the photo page because you already have the common shared code.
Right.
So this is a packaging tool that works really well on the client side, and it also supports an isomorphic node where you basically say -- target node, and it'll make bundles that work in Node as well.
Handy.
Yeah, it's pretty cool.
So it sounds like you're both working on fairly large user bases. How does this solution scale?
I think there's different ways to think about scaling. So
Okay.
I mean, there's like on your servers to many users. There's also scaling to a developer team.
Right.
So for us, we released a library called Render, R-E-N-D-R, and it's our way of like modularizing that part of it. So we have a Backbone app, or it lets you run your Backbone app on the server, and that's scaled up pretty good for us. Like it runs all of our mobile website, m.airbnb.com is all running on that, so that it's all rendered at the server and in the client. But we have yet to, phase out our entire Rails app, right? Like we've got a 5 or 6 year old Rails app, and so it'll be a while before if we even try to replace that entirely with Node.
Okay.
But I mean, I think it does pretty well scaling as far as Node's fast.
Right.
Web servers are generally I/O bound rather than CPU bound, so
right.
It does great. We replaced a number of Rails servers with like just a handful of Node servers.
Yeah. It's pretty interesting too, I think, because Node is so fast because it uses this just-in-time compiler.
Right.
So certain systems will bring up a new JavaScript VM for each request, and you'll get pretty poor performance there because it takes a while for your code to get parsed and for your code or for the optimizer to understand like what the types of your program are, and it has to run through it a couple times.
Sure.
So you need to kind of keep your process up for a long time. To really get the performance benefits, but there's also a downside, which is if you're keeping your process up, it's possible to leak data between requests. So you have to be very careful to not store user data in a global, for example, that might maybe it's lingering from a previous request. So designing a system around there. There's also some Node APIs that help you here, like VM create context and things like that. So there's a couple of different things that kind of crop up when you go to scale like that.
Right.
Yeah, it is a different paradigm, right? Because you have to start thinking about each piece of code you write might run on either side of the wire, and so it takes more discipline. And I think with proper tooling, you could have like a linter or different different build tools which would help this. But I think one thing that's really enabled this is the number of build tools in the Node world, and just in the front end world, that happen to run on Node, is really exploding right now. There's Grunt and Gulp, both of which we use. They're kind of alternatives. There's like Broccoli is a new one, an alternative to these two, and Esprima is like a foundational library at the heart of Browserify. It's also how Meteor does their isomorphic parsing. So Meteor is a pretty famous app. I've got their sticker right here. Meteor is awesome, right? They're like really smart developers. They're solving a really big problem, and their entire infrastructure, their entire framework is isomorphic at its core, and they're really using the power of JavaScript everywhere. They're betting the farm on that basically. I think they're kind of like the bigger player, and then Render is like a smaller library.
Right.
But it works actually very well with React. In fact, there's some integrations because React is like a view layer, and Render is like the data layer and the routing. You can mash them together.
It's really interesting because Render was developed in isolation of React, and like we didn't know anything about each other while we were developing, but we were both working on this isomorphic thing from kind of a different angle. Like Spike was really concerned with routing and model management and how do you sync the state between the client and the server, and React was more about how do we render the same UI on the client and the server, but the way you get your data there, like we don't care. So when we kind of first, when I was working on the isomorphic stuff, they launched render, and I was like, I really wanted to launch that first and be known as the people that did that. But we ended up kind of like meeting up and realizing that our hooks for kind of isomorphic rendering looked almost exactly like the hooks in render. Oh. So it was literally like snapping together two pieces of Lego blocks. And it just worked. Like we had a 20-minute meeting, we got an app running in that time.
Yeah.
Well, it sounds like there's an awful lot of synchronicity between your projects and other projects that use isomorphic. Where do you see it going in the future?
That's a good question. I was just talking with Matt of Meteor about this a couple minutes ago, and we were just both saying that we think that 2014 is the year.
Okay.
The year of the isomorphic JavaScript. We're going to see more and more libraries pop up, build tools, like apps that support this. Artsy.com. Artsy, they released easel.js, which is like similar to render backbone apps on the client server. There's like more and more things popping up, and what's cool now is there's enough kind of lower level libraries that you can, like you said, you can snap together these smaller modules to create an isomorphic app. Like you don't need this like big framework to do it anymore. It helps. Like with Meteor, it just solves a lot of your problems, but
yeah, I think if I can say something somewhat controversial, I think that the web component standard that's coming up is going the exact opposite direction that we need to go.
Okay.
So it's all about, web components is a set of standards that's all about building richer APIs into the browser that are driven by JavaScript.
Right.
And one of the major points of isomorphic JavaScript is you need to be able to generate a static HTML page on the server, send it down, and then like reanimate it on the client. And with web components, you can't use any of the APIs without a browser. So you need to either run some sort of browser simulation on the server, which will be too expensive, or you have to send down only parts of the page that aren't web components. And at that point, if you want to bet big on web components, you really can't if you want those benefits.
Right.
So I'd really like to see us focusing more on solutions that will work in an isomorphic world, in a world where we can share code between the client and the server and really get the performance as well.
Yeah, that's an interesting point. I've been thinking about that. People often ask me what the story is with Angular and isomorphic code, and there isn't really one. I mean, you can, of course, like any of your application logic, your like domain logic can be just isomorphic, but as far as the view component, Angular is based around DOM, right? So you add attributes to the DOM, and there's not a clear story of how that would be rendered in the server. I mean, like you said, you end up needing a DOM. And I think our conventional wisdom now is that DOM is really slow, especially server-side DOM. But I wouldn't be surprised if some smart person would create a really good binding to Blink or WebKit on the server. And there's a few, but I think at some point that problem will have to be solved. But that's a huge unknown for me as well, how those things fit together.
We'll see how it turns out. I mean, it's one of those things that there's this like Cambrian explosion of different ways to do things right now, and we're all kind of trying out different approaches. So I can say, for React, we treat the browser as this like thing that we don't want to deal with, and we treat it like a remote rendering engine. So we barely ever touch the DOM, and a lot of cool stuff falls out of that. Just like a lot of cool stuff is falling out of the web component specs as well, like Shadow DOM lets you style like native components like dropdowns, which is something that we desperately need. But I think that we're all convincing each other of our different ideas, and I think that we're about to see a really kind of great combination soon.
Well, it sounds like it's an exciting time to be in JavaScript.
It is.
Yeah.
Well, thank you both very much for your time, for coming in here to talk to us. We appreciate it.
Thanks, Brian.
Thanks.